We talked earlier about what a function is and definitions, and now we're going to talk about the function notation and how we write a function and how we call things functions. And then we're going to talk about the composition of function, which is functions within functions. And I'll explain that as we go. This is kind of what I look at. This right here, f, this is pronounced f of x, not f times x. And this would be a different function. We'll call that h of x. And functions we just name them by letters usually. In the x part is what we call the input. So I like to think of this as like a function machine. So let's say this function said f of x equals, I don't know, x plus 3. And what would happen is we take an input, let's say an input of 7. So if I wanted to figure out f of 7, I would just take a 7 and I'd throw it into here. And what would happen is inside of here, this function f takes whatever the input is and adds 3. So this becomes 7 plus 3, and it spits out an answer of 10. And that's what, so f of 7 would equal 10. And if I put a different number, if I put f of 12, I would put a 12 in here, and 12 plus 3 would be 15. This one here is a different function. Let's say this function is x squared. So what this does is it takes any number that I put in. So if I put h of 7, I'm going to take a 7 and I'm going to throw it into here. And it's going to say 7 squared because that's what h does. It takes whatever number I put in and squares it. And then I give out an answer of 49. So that would be h of 7 equals 49. So that's the basic concept of how functions work. And we're going to kind of combine some things. Let's look at a couple practice problems here. So here f of x is defined as 2x plus 1. What that means is we take every x, and whatever we have, we multiply it by 2 and then add 1. So this would just be 2 times negative 3, because the x now has changed to negative 3, plus 1. So that's negative 6 plus 1, which is negative 5. So f of negative 3 equals negative 5. And now I'm looking at g of 2, which means I go to function g, which is over here. And each x now is squared. And then I add the number of x, whatever x was, and I add 1. So this would be 2 squared plus 2 plus 1. So that's 4 plus 2 plus 1, 6 plus 1. So this is 7. So g of 2 is 7. And that's pretty straightforward. I think we can figure that one out without too much difficulty. It gets a little confusing when we do stuff like this, where we're embedding functions within functions. So this is a little tricky. The way to look at this is to say, well, wait a minute. G of 3 has a value. So over here, I'm going to say g of 3, and I'm going to do what I did before with that. I'm going to put a 3 in here. So that's going to be 3 squared. The x's now have become 3's. 3 squared plus 3 plus 1. That's going to be 9 plus 3 plus 1. So that equals 12 plus 1, 13. So g of 3 equals 13. But that's g of 3 right here. So I take this and make this 13. So this now becomes f of 13. And I know how to do that one. I simply, for f of 13, I change the x here. I'll go to function f now, change the x to 13. 2 times 13 plus 1 is 26 plus 1, 27. So the answer of this whole thing is 27. Similar, now I have g of f of 3. Now you might think it would be the same answer, but it doesn't always work that way. So we're going to go and look at that. And this inside of here says f of 3. So I'm over here, I'm going to, on the side, I'm going to figure out what f of 3 is. And that's going to be f is function over here. So it's going to be 2 times 3 plus 1, which is 6 plus 1, which is 7. So f of 3 is 7. So that means this number right inside of this parentheses, this entire thing is 7. So this becomes g of 7, which now I go to function g over here and change the x's to 7. 7 squared plus 7 plus 1. 49 plus 7 plus 1. 56 plus 1 equals 57. So this answer would be 57. So the structure is really simple. We're putting a lot of stuff together with it. Individually, it's an easy problem. It's just combined, it looks a little complicated. Then they complicate us now with putting a whole different notation. They write this FOG thing, or whatever this is, this little symbol. What this means when you see FOG, and you'll see this just means F of G of 2. So the whole thing, this FOG just is another way of writing this. So it's the same thing as this. So now I go through the principle I did before. I got to figure out what G of 2 is. And that's going to be 2 squared plus 2 plus 1, which is 4 plus 2 plus 1. We did that already. That's 7. So G of 2 is 7. I take 7 and replace it here. It becomes F of 7. And that becomes 2 times 7 plus 1. 14 plus 1 is 15. So this answer here is 15. Now the last thing I'm going to show you is where it gets a little confusing, because here we don't have a number here. We have G of x. But what this means here, I've got to figure out what G of x is. Just like here, what I did was I figured out what G of 2 was, and then I replaced it right in here. I figured out G of 2 was 7, and I took 7 and put it in for this x right here. In the same way, I'm going to figure out what G of x is. Well, there's no figuring out. This is G of x. So what I'm going to do is I'm going to say F of x squared plus x plus 1. And that's really what, because this G of x is the same thing as x squared plus x plus 1, because equals means the same thing as. So this means I take every x and replace it with x squared plus 1. So that becomes 2 parentheses x squared plus x plus 1, and then plus 1. 2 times this whole thing is what's replacing the x. So that becomes 2x squared plus 2x plus 2 plus 1, which is 2x squared plus 2x plus 3. So that would be my answer to that. 2x squared plus 2x plus 3. Gets a little complicated if I have to square it, but I can simply, that's a whole nother process. So this is really all we're doing. We're just plugging things in and then doing our arithmetic. Okay.